Yeah, so we start from here today. This is last time we finish here. So any question till here from last class? Anyone? Okay, no question. So let's move forward. But please, if you have any question, so you are free to ask and you can send me the response. And Riley, I'm sorry I did not give you a response right away because I was busy with the conference. I was not here. I mean, it's online conference, but that keep me very busy for the whole day, and later I forgot. I is in Hawaii, and we have 6 hour difference from Hawaii to here in Florida, so keeps me busy till midnight. So here we have this example here. So it says that the language of all words that have at least two A's. So when we say we need to write the at least, I think I covered this also. At least two A's and exactly two A's. We did this, I remember. Here. So now at least one A and one B. So now if I need to write the regular expression where my language must have at least one A and one B. So what is the thinking process? Thinking process is this, that whatever minimum is required, first write that and then think about make it complete for whatever the whole sentence. So now if you see this, it says at least one A and one B. So I will say, okay, if it is one A and one B, I will write on the back, this slide on the back. It has more space. So it is, we can write 1A and 1B. Okay. And now make it come. So it does not say that where this A will come or where this B will come. So it means that it can come, anything can come before A and anything can come after B and anything come in between. So we are talking about A plus B whole star, A plus B whole star, A plus B whole star. But this, if we just write this regular expression, this gives us this guarantee that if you do not have this part or this part, then your word must start from A and finish with B. But whereas this is not the case in your explanation here, it says at least one A and one B. So we do not want, so it means that might be your word can start from A, might be your word can start from B. Yes. So this is the case here. So now we need to make it complete. So we must say then A or B, or might be initially A and then B. And then we make it complete that whatever happened before this, whatever happened in between this, and whatever happened after this. Now this is complete because now it does not have any order. It may start with A, it may start with B, it may end with A, it may end with B, and but uh, if you get at lambda from all these stars, you will get at least one A and one B. So this is the idea behind that. So now exactly this is what I just write before, and this is the final solution. Okay. So when you start working on this and you will become more experienced, you will figure out that sometimes when we write the regular expressions, it keeps some repeating terms there. Exactly that is the case in this also. But I mean for at your stage, I do not have this expectation. But gradually, when you become more experienced, so then you will learn that, and then you write. Uh, that way where you do not want to repeat any term which is already possible by you can create by some part of your regular expression, because it cost you with respect of the resources. It costs you when you do practical implementation of that. When you convert this into the actual language, into the hardware, and it will perform, it will create the same word by this part and then the same word by this part, which is possible, let's say. So then it costs you, it will be high in computational cost. So there you will figure out that how we can make it more intelligent, and then you will realize that if you replace this part, whole this part with this, so if you see that it has B there, it has A there, but it has B star and A star. So this is also exactly, it is not doing anything less than whatever we write here. It is exactly the same thing. But this is more intelligent way. Now here it is not repeating any term, and it is just it is a second solution of this, and it is doing the same job. So this shows that you can have more than one regular expression to represent the same language. Okay. Um, Now I just mentioned here also that these both are same thing. Okay. This is good thing. So now I have this question with you. Uh, if I have if I have this so this is my whole regular expression, or this is my this regular expression. Now, if I write this thing, do you think that this whole thing is equal to A plus B star? Anyone, please give me the answer. Do you think that this whole thing is equal to A plus B star?
I, I would say no, because this requires us to have at least one A and at least one B.
Very nice, James. Thank you very much. So now my question is, what are the missing terms in this big regular expression you see, and you add that those terms, and then it will be equal to this A plus B whole star. So I mean, what are the missing words, and which is not there, and we can add them. We can add a regular expression to entertain, to achieve those words which are right now we are not able to generate by this machine, and then we can say that this is now equal to A plus B whole star. So so now can I just create a word A with this? No. James, you agree with this? We are not able to create only word A with this.
Right.
Okay. And we are not able to create, if I say, only word which is just composed of all A's. So we are not able to add that. Okay. We create that word by this regular expression. I mean, I'm not talking about this, just this one. So now if we are not able to, so it means that we need A star here. If we have A star, so then this will be good. We are not able to generate lambda by this because it gives you guarantee that one A and one B, or B or A must be there. Even you get lambda from the other parts, B and A will be there, and lambda when concatenate with any word, it will vanish. So now A star, you will get lambda also. So this is one thing we have that. So are we able to generate only B letter from here? No. So or those letters which are just composed of B's, we are not able to do that. So we need B star also. So now if we add these two things, now if you see this whole thing, so it is good. It can generate only one A, it can generate only one B, it can generate all words composed of only A's, it can generate all words only composed of B's, it can generate all words which start from A and end with B, or start with B, end with A, and it can generate lambda. So in short, we can say that we can generate uh, A plus B whole star, that universal set with this. So now this is basically the thing that I am asking here. So I'm saying if you have this regular expression and this regular expression, find which words we are not able to generate by this regular expressions, write the regular expression for those missing words, and make it complete, make it equal to a plus b whole star. So now if I write a plus b whole star, or if I write this thing, it has same meaning. They both regular expressions define the same language, which is infinity language, which is a plus b whole star. But you can have more than one regular expression for the same language. So these both regular expressions are same. They represent the same language. I will ask you this kind of question in exam. I will give you one regular expression, it will do something, and then I will ask you, please find the missing terms in that, and try to make it complete for a plus b whole star. So then you do not write a plus b whole star. It means that you need to write, find the missing terms in that language. That what words we are not creating in this language. So you need to write the regular expression just for those words, and then it will be complete for a plus b whole star. So this is very important thing. Okay. So any question here? If you guys have any questions, so please ask. Otherwise, I move to the next slide. So now this is another thing, the language of all words formed from some B's, possibly zero, and all words where an A is followed by some B's, possibly zero, then this language also contain the word lambda. Now it says the language of all words formed from some B's, possibly zero. We have all B's, possibly zero. So all B's means B star. So now we can all B's, we can put B star or B plus also. We can put B star also, we can put B plus also, but it says possibly zero. So zero is only possible with star, it is not possible with plus sign. So this we are thinking about star. And all words where, so it means that we have another option of the regular expression where an A is followed by, so A is in the leading position, is followed by some B's and possibly zero. This gives us this information that this is star. And let this language also contain the word lambda. So now if you see this, if I write this regular expression, if I choose this path, I have option to choose only this. Plus means either this or this. You can choose one of this. So if I choose this path, from there I can get lambda. So I satisfied this part also. So now this is the regular expression of this. And if you want to see that what kind of the word it will look like, this language will create what kind of that, what are those words look like. So it will be look like this one, lambda. It will have just a we will get just from here, because b star will give you lambda. Just b will get from here, a b B, B, you can have two B's. So you will never see A in the following position. If there may be A, there may be no A, but whenever you see A, you will never see A in the following position or in between. It will always be in the leading position. So, but I mean, gradually, if you want to write it more intelligent way, more clever way, and which is not required at this stage. So then you may think that it has lambda there, because lambda, if it is lambda is there, so it will vanish. You never know that it has lambda beside it or not. And you take lambda plus a common, b star common from this one, and lambda plus a. So this also represents the same length, same thing. But I mean, if in exam, if you write this thing, it is completely perfect. Okay. So in general, concatenation is distributive over the plus operation. So you have, so now we are saying that if you have three regular expressions, R1, R2, R3, so then if you have this in this format, so you can concatenate R1 with R2 or R1 with R3. So they will not change the behavior of the language, it will remain same. So exactly if you have regular expression in this format, R1 plus R2 and R3, and you apply distributive property R1 concatenate with R3 and R2 concatenate with R3. So this will not change the language, it will remain the same language. It will give you the same result. Whatever the result you will get from the first one, you will get the second part will give you the same result. Okay. So now here I mentioned that AB star not equal to A star B star. Why? Anyone?
Because A B star, every time it generates like another part of it, it's going to be the set like whole word A B, whereas A star B star is going to be the individual letters A or B.
Very nice. Exactly, this is the perfect answer. So AB star will consider AB as one entity. You will never see the word only A here or only B here. You will always see the combination of AB, 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 AB because of star or lambda. But A star, B star, it's a star on individual letter. So you might get lambda from here and you will get a from here or lambda from here and any letter from here. So it is possible that you will just get a or b or or combination of a b there, but you will never see b a. So now my question, can we see b a in this? We will never see b a because it does not has uh, plus sign in between. So that's why it follow the order. Whenever you have A or B, it will always be A in the leading position, B in the following position. So you will never see this word there in this A star, B star. Okay. We can how if you want to see that, so then you will write this something like this, outside star also. So now this make it possible that you can you can yes. So now you can see BA there, but because of this. Okay. Does it make sense? So any confusion here, guys, with this? That why this will create this thing BA, this will not create that. So now what I want to say that A star B star is not equal to A star B star and the whole star. It is not equal to that. Because when you have star outside, it means you can use this term again and again. This means you can use this term again and again, this term again and again, but follow the order. But when you use this again and again as because of this star, so then let's say first time you use this and you use B, you get lambda from here. Because of this star, you reuse this and you got A, you got lambda from here, so you can get BA. Whereas BA is not possible in this part. So that's the thing here. Now we are saying example of distributive rule here. A plus B, A plus, now let's say you have a regular expression which is this, and if you apply a distributive property on that, A B star plus C B star, this represents the same thing. Whatever the end result of this, you will get the same end result with this language. Okay. So now if you see that if we can say that we have two languages, let's say S and T, and I am interested to find S plus T into this, which is our union set. So it only means that you just combine all the sets of this language A, B, B, A, and AB. Just for the clarity, we do not write the duplicate terms. So we will just write A, B, B, A, B. So we do not write the duplicate terms. So this is if I ask you to write the S plus T, so it means that just find the union of two sets. Here order does not matter. So if you write AB, so this is equal to, if you write AB before and then A and then BB, so it is same thing. It has no problem here because you are just writing all the sets there. But if I ask if we are interested to find the product set of that, okay, so then order matter. If S is first, so all words of S language will be in the leading position, and all words of the T language will be in the following position. You will never see any word of S, a new word of this language, and the S, that word have any word ending with the word of S language. So now this will be all possible combination: A with AA, A with AB, and then A with, sorry, B with A, and B with AB. So here it is this. Okay, here order matters. So you do not write A, B, B, B. So the T, all words from T will be in the falling position. All words from S will be in the leading position when you are talking about the product set. Okay, that's very nice. Uh, Now we are saying that language associated with the regular expression. So this is just what I just explained to you. What we did before, it is just a formal definition of that. So we are saying that the language associated with the regular expression, that is just a single letter. If you have just in your language you have just lambda. So which language is associated with regular expression? It's a regular language, and the language associated with. So if you just want to create a lambda, so this will be also a regular language. It is a one word language. So if you have a language L1 and it is represented by regular expression R1, and you have language L2, it is represented by the regular expression 2. So if you concatenate these two regular expressions, this will be a new language. If you find the product of a sum of these union of these two regular expressions, this will be the union of these two languages. So if you find the have a language one, and if you find the clean star of that, this will be clean star of the regular expression of that language. So this is basically we already see that it is just a formal definition of what we did in the previous past slides. Okay, now we are saying that let L be a finite language. So it is a language which is, so now let's say you have a language, and this language is not infinite. It has very few words, let's say 5 words, 3 words. And let's say I have a language and it generate these 3 words. This one. So this is my language and it generate these 3 words. That's it. So now if you see that these words does not have any pattern there. So these are just random words. Or let's say I have a language, it generates one word A, another word B, and then another word C. That's it. So now I do not find any pattern here in these words. That what are, and that's it. It only generates 3 words. So now if this is the case and someone asks you to write the regular expression of that, so do not need to worry about find the pattern and write a regular expression the way we writing here. So then just combine all these words with the OR operator, and that will be the regular expression of that language, because this language only generate 3 words. So we can say that this is a language and it can generate either A or B or C. Exactly, if you see here, it has 3 words. I just concatenate these 3 words with the OR operator, and this is the regular expression of this language. Okay. Now, this is another example here. You have a language, it has 4 words. I generate the 4 words here with the OR operator. But because we are very much familiar with the set theory and taking common, and I figure out that if I have A plus B, this will give me the same thing. Look at this one: A multiplied by A with A B, B with A, and B with B. So A, all these terms are here. So this is exactly this thing. But this algorithm, it will not help you when you have a language and it has infinite words, because you cannot write all possible words and write the regular expression of that. This is only possible when your language is finite and it has limited words. So then you can use this method to write the regular expression. Okay. So now we are saying that, let's see this example here, green star applied to a sub expression with a star. So now we have a plus b whole star, a plus b star, and then whole star. So now if you have this thing, so it says that this is equal to this. so so now if you do you remember that in previous chapter we solved this thing that s star is equal to s double star. Okay, so exactly same thing happened. So b double star double b star star is 2 star, but it is equal to 1 star, and a is there, and this star is also on a, so it is basically the same thing. So this is equal to a plus b whole star. And but if you have this language here and you put star here, this is not equal to a plus the way we are handling there, a plus a b whole star, because this uh, so by this language you let's say, because this star is here, so we are saying that this is not equal to this. Okay, because we have star here, so this star means that you will get lambda from here, from this b, but here this b does not have star independently, so here it will consider this a b will consider as one term. So this star means this star is here on both terms or here on both terms. So here it means that it individually this will have star, so might be you will just get a from here, because of b star you will get lambda. So this is different from this one, so they are not equal to this. Okay. So letter A and letter B are in regular in language A star B star. So now I already explained you that this is if you have this thing and it will equal to this. So I already explained you this. Okay. Look at this one here. Okay. So is it possible to determine if two regular expressions are equivalent? Yes, we can do that. So, like, what does it mean that if you have these two regular expressions, look at this one. So, we have these two regular expressions. And if we do not know the previous slide, so it looks very different. This is one regular expression and this is another regular expression. Is it possible that we can figure out that both regular expressions are equivalent and they represent the same language? So, so far, with the algebraic rules, it is not possible. We do not know, but with the algorithm, yes, we have. By algorithm, we can figure out that both regular expressions define the same language. So, what does it mean here? Two things. Uh, you have regular expression one, and you have another regular expression two. When it says one thing is you figure out this regular expression represent which language, and this regular expression represents which language. If both languages are same, then they are equal. If both languages are different, then they are not equal. So this is one way. You need to know which language they represent. But here it is not saying this. It is saying that you have regular expression 1, you have regular expression 2, and I am not interested to know what language they represent. Is there any way to go without going into that complexity that both regular expressions represent which languages without knowing the knowledge of the language, just by looking at the regular expression? Is there any algorithm which will tell us that we do not know what is these languages, but whatever these two languages, these both regular expressions represent the same language, or they are representing not the same language, they're representing two different languages? Yes, it is possible. There is very nice sophisticated algorithm for that, and we can check that by using that algorithm. It's a long way, but yes, algorithm exists, and you will see that in coming chapters. Okay? That without having the knowledge of the language, you can figure out whether both regular expressions are equal or not equal. So yes, by algorithm we can do that. So I'm so I'm positive that you guys are uh, following what I'm saying. If you have any questions, so please feel free to ask me a question and uh, uh, interrupt, use your mic, and you can I can answer your question. Okay. So now, understanding regular expressions. So now this is another example here. So now we are looking more examples. Words with the double letter. So now we are saying that we have a word and it has a double letter word. So double letter means that the word must have two A's or two B's, something like that. Two consecutive letter A's and B's. So if you just write that, so we are saying A and BB are double letter word. It does not say that where this letter will come. So this letter, it means that this letter will be anywhere in the this word will be then it will be anywhere this will happen. So then you can write A plus B whole star before that and A plus B whole star after that. Now it has double letter there. Okay? Write a word with double letter. So minimum requirement is met with this one. So now we are saying that words without a double letter. So A, B, so it will never have the double letter there. You will never see uh, two A's or two B's there because it will always be combination of A, B, A, B, A, B, A, B, or something like that. You will never see two consecutive A's or two consecutive B's with that. So adding these choices also that start with B and end with also with A also. So double letter and start with B and end with A. So look at this one. So we can add. So this is already we figure out here. But now it is saying that can you add these choices that start with B and end with also with A also. So look at this one. Start with B and end with A. So we write the lambda here because might be we are not interested to start with A, B or end with A. So also it is optional. So in that case you will choose lambda from here and lambda from here. But if you want, so you can have now start with B also and end with A. So you can have that. Okay. Combining these two, now if you see this, so this is with double letter and this is without double letter, and we can say that it is equal to we say that this is equal to A plus B whole star. So look at this one. So all words with a pattern. So now if you combine these, so what is this regular expression if you combine these? You will get, it is not A plus B whole star. So this is just the all words with double letters and without double letters. So this is something like this because you cannot generate only A from here because no, you can generate only A from here and you can generate only B from here. You can generate A by this and BB by this and AB by this and BA by this also because if you get B from here, you got lambda from here and A from here. So it is BA. So yeah, it is equal to A plus B whole star. So this is equal to combining two will give you A plus B whole star. Okay. So this way you can figure out that whether this is equal to A plus B whole star or not. So now continuing even further. So now if you see this that all words with the pattern AA, all words without the pattern AA. So now this is a regular expression where you will not never find double A, but you will find all other words other than this one. So this is a regular expression of that. So if you see this B star A and then so you will never able to combine A with another A after that because before after that it is B and this is star. Whenever you will always have this combination there and you can have as many B's before that as many B's after that or only A here if you want, but you will never have two A's here. So this is very perfect regular expression of that. All words with double A. So this is double A. So now if you combine all these, so all words without double A and with A, so this is equal to A plus B whole star. And you can you can combine these and take common and all that and make it more complicated if you want and looks good to your eyes, but I mean it is same thing. Make sense? So thing is that here you can write regular expressions by combining all these things, and this way this is very important. This is part of your, I think, first assignment, and this is a very famous regular expressions for even language. So you have a, just look at this one, how long this is. So we are saying that if you have a language and it is even, so this is a regular expression of that. So at some stage you will figure out that it goes beyond the human mind, that he or she can predict, or by any particular method they can write the regular expression, because it is when you are talking about 100 states of a machine, so it will be very hard for you to write the regular expression of that and see that what's going on in this machine. So this is one of the examples. So even is not very complicated, it is just for machine job. So thing like this, and start and minus, and you have a b a. So this is the regular the FA of that, and you can generate the regular expression of this thing, something like that. Okay, so here we finish this, guys, and these are some leftover slides we have from the last class, and now you are good to finish your assignment 4, and you are good to. So now we have a quiz now, because I want to take your quiz for chapter 3 and chapter 4. So what is a good day you want to do that? Tomorrow or day after tomorrow? When you want a quiz of chapter 3 and chapter 4?
Tomorrow, please.
Tomorrow? That's good. Okay. I will create a quiz and you will have a quiz tomorrow from chapter 3. So now it means that we have quiz now tomorrow from chapter 3 and chapter 4. Okay. So do that and finish that, so then I can it will be graded. So how was your experience with the last quiz? Time was enough, sufficient, or it was you need more time, or how you feel that? It
I think it was pretty good.
was good. Okay, that's great. So we have this quiz now tomorrow, and I will do the same thing. I don't want you to restrict for the same time period. So let's say you will start quiz morning 8 o'clock, and you can finish this at 5 o'clock. Okay, so you can do this of your own time. So, do you guys have any other class, or you have only one class? In summer, are you taking only one class, this course, or more classes?
I only have this one right now.
I have multiple.
Okay, okay. So that's a good idea that I will give you the time range from morning 8 to 5 then. So you can choose any time when you are free. Okay, this is good. So any question from this chapter, guys? Otherwise, we are done for this chapter. This is your time to ask me a question. You know that assignment due date is tomorrow night, and that will cover first 4 chapters. Okay, this one and internship. Okay. Okay, so if there is no question, I will consider your silence as yes. I will close this and
Professor,
yes.
if you could you go over the even, just so I can understand a little better?
Okay, so you are just on time, which is chapter 4. What is there? Okay. So even is this, like when we say even, so it means that we have even number of A's and even number of B's in our language. If you count, it will be even. So now every word in even has even number of A's and even number of B's. So now if you, so when we say even, so it means that either 2, 4, 6, something like that. Yes. So now we have uh, we have two A's or we have two B's. This is even. But is this gives you a restriction that you will have only A's and B's. What if we have a word which is combination of A and B? Okay. So if you have combination of A and B, might be it will start from B, B A, and but if you pick any one of this, it is not even. It is odd. One, because one A and one B. So then you need, without plus sign, you want, because when you do not have plus sign, you are saying it must come with that. This means either this or this, and this thing, whole thing what we write is coming here. So now we are saying A or B. So just add that with as many A's as many B's, and after that again AB and BA, because if you see this, now we have one A, one B, now second A, second B, or this one, any combination of this and this make this thing odd, uh, even. And we have, and then we are saying that whole this thing is, and you can beef up that with this thing. So A plus BB, and might be you have lambda here, so you want to repeat this as much as time. So we have star outside. Does it make sense?
Yeah, that looks good. Thank you.
Okay. So this is this, and I finished chapter 4. You have quiz tomorrow. Now let's start chapter 5. I think that I already posted this chapter on here. Let me publish this so you can see this chapter now, and you can access to that chapter 5. Now it is there. Okay, so let me open this also on my slides. Okay, this is a bit long. So now, so far, you see that we can define the language by regular expression. And you know that when you define the language by regular expression, so it is a regular language. So now you can also represent a regular language by FA also. Okay, so how FA stands for finite automata. So what is this FA? FA means that if you have these three things, uh, this information, if you represent your language by this way, we can call that this is an FA. Okay, so what is this FA? So just let me show you how it will look like. It will look like a state machine, and then we can see here, and we can it will make more sense to us. Okay, so this is our FA. So it will look like this. Okay, this is our FA. Now let's read the definition of FA. FA stands for finite automata. So it says that a finite automata is the following three things. Uh, a finite set of states. So it will not have unlimited states. It has limited states, one of which is designated as the initial state. So we have FA, it has multiple states. One will be as a start state. And how you write the start state? You put the minus sign in that state. But FA does not have more than one start state, one of which is designated as the initial state. called the start state, and some, maybe none, of which are designated the final states. So might be you have final states, and how you represent the final state? By the plus sign. Might be you have one final state, might be you have more than one final states, might be you have no final states. Okay, and this will not, it is a valid FA. If you have an FA, it has one final, no final state, this is a valid FA. If you have an FA, it has one final state, it is a valid FA. If you have an FA, it has more than one final states, it is a valid FA. So look at this one in the definition, and call some, maybe none, of which are designated the final states or accepting states. And let's say we have one final state. And we have two final states. And then those states which are not final or not minus, they are just called the transition states. Okay, so they are called transition states. It is S or Z. You can put whatever the best spelling. So transition states. Okay. So now an alphabet. So this is the definition of this. Some restrictions. So now you need to understand FA will have only one final state. It will never have more than one final state. An alphabet summation of input letters. It will take input, and input will be summation. And summation, you are now very familiar with that. It is A comma B by default understanding. A finite set of transitions that tell for each state and for each letter of the input alphabet which state to go to next. So now these states are very well connected with each other by some transitions, and it has arrow here. It will tell you the direction of that. Okay. So might be possible they are not connected. Some are connected with each other with them. I mean, it's not that every state will should connect with everyone, but might be, let's say like this, it is not connected with these two states. So and so it is something like that. And then you will see those letters will be here written as a input here. Okay, so something like that. So this is the letter there, and you will see this thing there. The language defined or accepted by an FA is an FA is a set of words that end in the final state. So now you start always start working from the start state. Always start working from the start state. So now you traverse through the start state among all states. At some point, your word will finish. When your word will finish, because you move letter by letter, so you have a word a b a b a, and you keep moving, start from here, let's say a b a b a, something like that. And when you reach the last letter, if you are standing at the final state, it means this word belong to this FA. If you are standing at the non-final state, whether it will be a transition state or the start state, so then it means that this word does not belong to this language. This is not a valid word. So to acceptance, this word should be finished at the final state. So the language defined or accepted by an FA is the set of words that end in a final state. If W is the language defined by FA, then we also say that FA automation, finite automation FA accepts this word. So if W will be accepted, it will finish at the final states. We can say that this word belong to, because this is a mathematical model. It represents some language, and this word belong to that language. And this language is a regular language. FA and regular expression both represents the regular languages. Okay, so you will see some example. You will have more understanding. So how it works by being presented with an input string of letters that it reads. So you have a word, you read that word letter by letter, you traverse from on the FA. So the set of all strings to leave us in a final state is called the language defined by the FA. or if it does not, so it means that this word is not accepted, it is rejected by FA. So this is the idea behind that. So word should finish at the final state. If it is not, it will be rejected by that FA. It means this word does not belong to this language. Okay. So now we have this example here. Summation is equal to AB and states is equal to X, Y, Z. We start state is X. We are saying that we have summation is equal to AB, and it means that all words which you generate in this FA will composed of either A or B or A or B. You will never see C there or D there. Only these things will be there. And states, we have only three states: X, Y, and Z. So on my side, it is heavy rain outside. So now we have these three states. Okay, so X, Y, and Z. Normally, we do not write the name of the states, but it is written here, so I am just writing that. Okay, so it says that start state is X. X is a start state. Final state is Z. Z is a final state. This is a transition table. It will tell you what happened if you are at X. So you are at X, and if you receive A as input, you will go to Y. Okay? So I have A as input, I will go to Y. I am at X, I receive B as input, I will go to, why this? I will go to Z. Arrow must be there. Huh? So then I have at state Y, and I will receive A input, I will go to X. I'm at state Y, I receive B input, I will go to Z. I'm at Z, I receive A input, I will stay at A. Z, I receive B input, I will stay at Z. So either you draw two loops like this, or you can also combine these two loops and you can say you are here A comma B. It is the same thing. Okay. So now this with this way you can, if I give you this information, so you can draw the FA of that by looking at this information. Okay. So now we can check that if we have the word A, is this the word belong to this language or not? We always start from the start state. So we start from X, we receive our first input A, and we go to Y. Then we receive our second input A, then we go again back to X. Then we receive our third input A, and we again go to Y. And at the third A, the word will finish. And you are at the Y state, which is a non-final state. It means this word does not belong to this language. It should be rejected. Okay. And now let's say we have another word here, A. So we always start from X. So we are at X and we have a word letter A. It will take us to Y. Another letter input is A. It will take us to again X, this thing. And then B, third letter is B. It will take you to Z. Once you reach at Z, there is no way you can go back from this state to where whatever the letter you have, either A or B. And then you receive A, so you will be have A, and it's a self loop, and you will finish here. And you see that this is a final state. It means this is a good word. It belongs to this language. So it will be accepted by this language, this FA. This way you do the traversing among the FAs, and you can figure out that how this will work. Okay. uh, Guys, you are free to ask any question if you have any questions so far. Is it good? Do you guys understanding what's going on?
Yeah, it makes sense to me.
Okay, that's very nice. So now you see the practical implementation of this. So we have a language, and now we are drawing the mathematical model of that language. And later once you draw that, so this is the next. So if you are in computer familiar with the computer engineering or the assembly language, Now then once you draw this thing, then you then you can convert this into the hardware. And once you convert into the hardware, so this is a machine which will behave exactly the same way the way you design this language. So now I mean this is this is a practical implementation of this, that whenever you design any circuit on the paper, so that is the case here, and then you convert that onto the hardware. And then any automation industry where it requires just to design one small language for one robotic arm or one part of the machine, so this way you can design that. So multiple machines, so CNC operators and all those, so those are the operators, but you are the scientist, so you can design the machine for them. Some big industry where they have their own they have their engineers, and they can design those machines. They are dealing with some small problem, and that they want to automate that, and they ask and there it requires you to design a small circuit board which can generate perform that task. So then you should be aware that what are the different states, how the data flow of that area, and how you want to automate that thing, what should be done, where it should start, where it should finish, what should never be happen in that, and what are the maximum possibilities, what are the possible paths, what are the possible inputs, what is the output. And you draw that in this way, and then you convert that into the hardware, and then that's it, job is done. So this is very important information, and that is a practical implementation of this. And look at this one. I just draw this here, and it is the same thing. So I told you that if you have this way, you can combine these two loops because it's a self loop on the same state, and you can combine this with a comma b. Okay. So now again, this is for your practice. You can see that whether which word belong to this language. Okay. So you can just do the traversing and you can see that. So now just for you, I already did this traversing. Let's say I pick this word, and in this state, how I go there. So if you see this word, so you look at this one, A, B, and then B, A, B, and then A. So it finish at Z, and this will be accepted by this machine. And this word also, this is the way you can traverse on the FA, and it will also finish at Z, and this will also be accepted by this machine. And if I ask you, write the regular expression of this machine, write the regular expression of this FA. So then you need to see that how we read this, because to write the regular expression you need to understand what's going on in the language. So now if you see this, we when we always we are forced we know that we always start from this state. Okay, so if you are here, you can start with the A or you can start with the B. And if you have A, it has a loop here, and if you have B, it has a loop here. After A, you can have A or B, and if you start from B, you can have A or B. So it means that we are talking about A plus B whole star. But how you write the regular expression? First, you choose how what is the mandatory part of this machine, that every word should have that thing uh, to be accepted. So if we see here, if you are at the start state and you reach to the final state, how you reach there? By B. It means that you must have one B in your word. Okay. And here it is in the starting position. But now let's see this path. You start you if you choose this path, you can start with A. You can have as many A's, but as soon as you have B, you reach to the final state. And then you don't care. You have A as many as A's or as many as B's. So this tells us that if whatever the language you have, you do not care from where it start, from where it end, but it has, if one be there, your word will be accepted by this language. So we are saying if I have one B in my language, in my word, and exactly if you see, if this word, it has one B, once you encounter this B, you will be at the Z state and you are in this, and there is no way out. And once you encounter this B, you are all this will be, look at this one, 1B, everything will be in the Z state. and whenever you encounter B, so you are in this state. So you will never go out. So it means you, if you have one B, this gives you guarantee in your word that that word will be accepted by this machine. You do not care what is coming before that and what is coming after that. Okay, so this is the regular expression which will tell you that what's going on with this machine. So idea how to write that. First you need to see that if you are at the start state, what is the path, what are the thing which will take you to the final state. So if you figure out that, and then you can figure out all those loops and the other parts of the machine. Are we good? So this is quite a little bit complicated. This is only the hard thing, I believe, and then it will be easy. This is the only hard chapter, I believe, and then life is easy. It's not that complicated. Okay. So do you want me to continue or you want me to stop here? I can continue, but I want to see that if you guys are happy with this so far. Do you guys understanding all these things?
It makes sense to me.
Okay, so let's continue then. So now we are saying that we are happy with this. Okay. So now look at this one. This is another FA. Uh, First of all, we need to see that this is valid FA or not, that this machine is good or not. So what are the conditions? So look at this one. These are the conditions for this machine. So it should have, what are the conditions? It should have one start state. Yes, it has one start state. We don't care about the final states. Final state may have, may not, more than one. So if it has one final state, it is good. But if it does not have, it is okay. It has letter by letter from each state. It is letter by letter A, B, and A comma B. A comma B means it has two loop here. One loop for A, one loop for B. So this is valid FA. This is good. And now our job is to write the regular expression of this FA. So how we write that? So we need to see that how we reach to the final state from the start state. We can, if you are here, you can reach by 1A. So we have 1A, or if you are here, you can reach by 1B or 1B. And this is the start because you cannot have anything before that. Okay. Once you reach to the final state, you do not care. You have 1A or 1B or as many A's or as many B's because this is a loop. So it is A plus B whole star after that, and this is the regular expression of this. But if you intelligently, you see that this gives you guarantee that you must have one A or one B, so it is also equal to A plus B instead of star plus sign. So, I mean, whole thing is this, but if you compact that, it is also equal to this one. It is the same thing. So this is the regular expression, and how to draw the FA of that and this thing. Okay. So now whenever your start state will have a final state. What does it mean? It means you are at the start state without giving any input. You are at the final state and the word will be accepted. And this is lambda. So whenever you wanna, so lambda is a word which has no letter, and but it is still a word. So when your start state is a final state, so it means that this machine will accept lambda because you are at the start state and you are suddenly at the final state also, but you did anything. You did not create any letter. You did not give input any letter, but your word will be accepted. So it will be lambda. Okay. But other than that, you can have loop here of A or B. It means you have as many A's as many B's. So it means, so this is equal to A plus B whole star. And this is valid FA because it has one start state, it has final state, and it is taking care of all transitions letter by letter. So this is a valid FA, and this is a regular expression of that. So this is good. Now, FA that accepts no words. So now my question with you, is this a valid FA or not? So Nabhan, is this a valid FA or not? Nabhan Aziz, is this a valid FA or not?
He seems like it. The middle is the final state, but I don't think so.
So you are saying this is a final, this is valid FA. This is what you are saying?
Uh, I'm still thinking. I don't think it is.
So you think it is not a valid FA?
No.
Okay, let's think loudly. So why you think this way? This is perfect. You what you are thinking, I'm not sure it is right or wrong, but this is good. But let's loud think with us. So we know that why you are thinking that this is, so what problem you see here?
There's only two states.
But that's not a problem. We never say that FA will have, you see in the previous slide, it is just one state here. So this is, so that's not a problem.
Okay.
I mean, number of states will never be a problem for the validity or invalidity.
Could you repeat that?
I'm saying that number of states will never have, FA does not have any restriction with the number of states. It has only one restriction, that states should be finite. It should not be unlimited. But number of states will never figure out that FA is valid or invalid.
Okay.
So now let's say what are the checks we need to run in our mind when we check the validity of any FA. First check, it should have only one start state. So does it has only one start state? Yes. So
Yeah.
this check is done. It may have one final state, it may have more than one final state, it may have no final state. So it means that we this also satisfies that thing, it has no final state. But if it may have one final state, it may have more than one final states, or may have no final states. If you see the definition in this first slide, so look at this one. I made so mess here. So if you see, some, maybe none of which are designated the final states. See, so it means that this is good. It passed that. Other than check, it should have letter by letter all transitions from one state to another state. You will never find a word here like A B. You will never find that. It should always be a letter. Letter and letter. A is one letter, B is a letter. So this is it. It checked that. So yes, this is a valid final state. This is a valid FA. But it does not have any final state. It is not doing anything, because we know that the word will be accepted when it will be end at the final state. So this is a, so what is this language? It is a phi language. It is not doing anything. It is not lambda. Lambda means there, so lambda, it is not lambda. If it is lambda there, this is lambda. Look at this one, when you have the start state as a final state, so then it will accept lambda. So for lambda also you need a final state. So if you do not have final state, it will not accept the lambda there, because lambda by itself is a word. That's another thing, that word does not have any letter. But to accept that, you need a lambda there. So to need a final state there, this does not have any final state. So this is a valid FA, but it is not doing anything. It represents the phi language. So same transition condition leads to multiple different possible states transition. Uh, no, I was talking about the second one here. Oh, okay. The second one is so now what about the second one? This one. Anyone, is this a valid FA or not? This one. Who will give answer? Any volunteer?
It looks valid to me, but there's no way to get to the final state.
Yes. So let's see this. So what is the check? Start state, may not final state, but it has, it's good. And letter by letter, a comma b, a comma b, and a comma b, but this a comma b is reaching from the final to the this one. So once you are here, there is no way you can reach there, no problem, but that's okay. So that's okay. So this is also a valid FA, but there is no way you can reach to the final state. So this, what language this machine accept? File language. So to be accepted to represent a file language, it is not necessary that it should not have any final state. If you have a final state, but there is no way to reach to that final state or final states, still that machine will represent a file language. Okay, so these are two examples where one machine has no final state, second machine has one final state, but you are not able to reach to that final state. So both represents the file language. Make sense? Okay, so this is good. So you guys are understanding. So now two ways to study FA. So starting with FA and analyze it to determine the language it accepts means to write the regular expression. So you have an FA, write the regular expression of that, or I will give you regular expression and write the FA of that. Okay, starting from a language and build an FA. So this is basically the idea behind that. So you can generate both ways. So example of second way, the language of all words within. So now how we generate the FA with from the English description of the language. So you have English description here, and we want to write the draw the FA of that. So what is this? The language of all words with an even number of letters over the alphabet A B. So it says that if you have A or B, the letters should be even. So the word size will always be two letter word, either two letter word or four letter word or six letter word. It does not say that it should have the same letters, two consecutive letters, but it says that the size of the word will be even. So the language of all words with an even number of letters. It is not distinguishing which letter. So might be you have a B, you have BA, you have AA, you have BB, but you have AB. So combination of two, it will always be something like that. So it is saying that even number of letters. Okay. So now if that is the case, so I will say that how I draw this. So I create one state here, another state here, and I'm saying that I can reach here so to this state by only A, or I can draw another edge to reach here by only B. I can combine two edges by or by comma, so A comma B. So this is not a word, this is again a letter. But this is, I just merged two edges, and then you see from here to here, if you reach here, you can reach here by A or B. You can start with A or start with B, and but it is one A or one B. You want to make it even, and then you are saying you can reach here back. Oh, sorry, I should not put plus here. So you can reach here back. This is a plus sign, and then it is again A comma B. So now if you have one letter and this is second letter and it's a loop here, you will never have one A. You will, all words which will be accepted will be composed of multiple of two letters, either AA or BB or AB or BA, whatever the combination, does not matter. So but always it will be two letters. So this is a FA for this description. Hope it makes sense to you. And it is easy, it's not that hard. Okay, so now look at this one. Oh, this is nice. We have a regular expression. So now you have this regular expression here, this FA here, and you want to write the regular expression of this, let's say, or we have a regular expression. Okay, let's do this way. Just find the regular. So let's say you have a regular expression and you want to draw the FA of that. Okay. So now we are saying that if that is the case, so how we do this? I think that I should stop here and I should start this in the next class because this is some now it requires more explanation. I want to do this by both ways, by so I don't want to stop in middle of that. So we will start this class now with a fresh mind tomorrow. And any questions so far here, so you can ask me. Otherwise, I think we are good. I'm stop recording.